Today we're going to learn evaluating, simplifying, and combining like terms. This is Chapter 1, Section 2 in your Algebra 2 book. So for a lot of you, it's going to be review to evaluate. We're going to be practicing plugging it in. So that's what evaluating means. Mainly it means plugging it in. And we're going to be practicing good practices or best practices to make sure that we're getting accurate answers every single time, because there's a lot of steps and there's a lot of things, a lot of pitfalls that cause people to get the wrong answer. We're also going to learn how to simplify things with variables in them by combining like terms. The first example is we're going to evaluate an algebraic expression. Basically, we're starting out with a minus 2b plus ab. Now remember that if the number and a variable are right by each other, that's an operation of multiplication. So this is 2 times b, this is a times b. And when we evaluate, they're always going to tell us, we're always going to know what to plug in when we practice this evaluating. Evaluating for a being 3 and b being -1. So the steps are to plug it in, and most importantly, put parentheses around everything you plug in. So here's my original problem. You should always write your original problem before you start. And then the next step is to plug in those values for a and b. Now I color-coded this for you so it's easy to follow. A is 3. Make sure that you add the parentheses. Minus 2. B is -1. Plus 3 times -1. Once you've plugged them in correctly, then it's a matter of just simplifying. Order of operations says you're going to multiply next. So 2 times -1 is -2. And 3 times -1 is -3. And then we go from left to right, adding and subtracting all that's left. So it's 3 is minus -2 means that we can add those together, because minus and a negative is actually adding. We would add the opposite, make it 3 plus 2. It's 5 plus -3, and the answer is 2. So I want you to try. Evaluate x plus 2x divided by y minus 2y for x being 4 and y being -2. Go ahead and pause that. These are the possible answers. Go ahead and pause that and try to do that problem. Okay, the answer is D, 4. If we go back and do this problem, x plus 2x divided by y minus 2y, and then we plug in the values for x and the values for y. Whoops, that wasn't right. That should be 4. And the value for y. And then simplify, following the order of operations. Multiplying would be first. 2 times 4 is 8. You can drop the parentheses after your first step, unless the number is negative. Then it's best to keep it in a parentheses to keep it separated from a subtraction sign. There's a minus sign, and then 2 times -2 is -4. So I'm going to keep that in parentheses because it's negative. And then next step is division. 8 divided by -2 is -4. So I have 4 plus -4, should stay in parentheses, minus -4. Going from left to right, 4 plus -4 is 0, minus -4 is +4. That's why we have D. To practice, you would do problems on page 15, 1 through 3. Example 2, we're going to be adding exponents to the mix. So we're going to evaluate with exponents. Anytime you see this caret, that means literally to the power of. So this is -x to the power of 2 minus 2 parenthesis, or 2 times the quantity, x plus 1, for x being 3. So first, write down your problem. You got x here and x here. and then plug in your values, put parentheses around them. Notice how I had the negative outside here, negative stays outside, it doesn't become inside. The negative is not part of the x, only replacing x. Nothing else changes but x, and that replaces exactly with what's written up here. So we got negative parentheses 3 squared minus 2 times the quantity 3 plus 1. Order of operations says you're going to simplify parentheses first, so 3 plus 1 is 4. Now I've got negative 3 squared minus 2 times 4. Order of operations says between these you would use exponents next. Now this gets a lot of students because they look at this and they go negative 3 squared. Well, that's not actually, well, it is negative 3 squared, but it's not the same as negative 3 in parentheses squared. Negative 3 in parentheses squared is negative 3 times negative 3. Here, this negative can be thought of, any negative can be thought of as negative 1 times that number that it's attached to. So, what would you do first here? Would you do exponents or would you multiply? You would do exponents. You would go 3 squared, which is 9, and then you would go negative 1 times 9, which is negative 9. We still have 2 times 4 down there, so that's what would be next. So it would be negative 9 minus 8. Notice how I dropped the parentheses here because I don't need them anymore. And the negative 9 minus 8 would be negative 17. That's our answer for this problem. So here's more practice. Negative d squared minus 4 parentheses d minus 2c if c is negative 3 and d is 5. So we would write the problem first, and then, we would plug in each value. D is 5, d is 5, c is negative 3. And then simplify. Remember that the negative is on the outside again, so this is 5 squared first, and then we're tacking on the negative. Over here, we have a parenthesis, so we would do this first. Inside the parenthesis, we have subtraction and multiplication. So multiplication's first. 2 times negative 3. 2 times negative 3 is negative 6, so we would write that in parentheses. Negative 6, bring down the minus, bring down the 5, bring down the 4, bring down everything else, and then keep simplifying your parentheses. Next step is 5 minus negative 6. Whenever you have a minus, you're adding the opposite. So it would be 5 plus 6, which is 11. So then we'd have 4 times negative 11 left over here, and negative 5 squared here. So between those two, multiplying and squaring, we are going to square next. Exponents is next. So we have negative 25, because remember you square and then tack on the negative. Now you're going to multiply 4 times 11, 44. Negative 25 minus 44 is negative 69. So I want you to try this one. Evaluate c times the quantity 3 minus d minus c squared, or c to the power of 2, for c being negative 3 and d being 5. The answers are possible. Possibly 6, negative 3, 10, and 27. Go ahead and pause it now and try that problem. The answer is B. If we look at this problem, c times 3 minus d minus c squared, we would plug in negative 3 for c here and negative 3 for c here. And then we'd have 3 minus 5 here, and we have the subtraction sign there. Parentheses are first, so 3 minus 5 is negative 2. Negative, so we keep the parentheses around it. Negative 3 out front, minus negative 3 squared. So we have times, we have subtract, we have exponents. So exponents are next. Negative 3 squared is positive 9, because it's negative 3 times itself, because the negative's inside. The negative's inside because it was part of our input. Okay, so now we bring down the minus, we bring down the negative 2, we bring down the negative 3, and now multiply. Negative 3 times negative 2 is 6. 6 minus 9 is negative 3. The answer would be B, negative 3. For more practice, it's page 15, 4 through 8. Next example, we're going to be talking about combining like terms. There are special cases, and this often isn't the case, but sometimes you can add or subtract like terms together. And these are things that have the exact same variables with the exact same powers. Those variables all have to line up exactly the same. The order can be different. Okay, variables order doesn't matter when you're multiplying, but you have to have the same powers and you have to have the same variables. So when you know you have like terms, you can add them together or you can subtract them. So here's a table that lists all the possible, well, not all possible, but some like terms pairs and some not like term pairs. And so we can go through them real quick. 5 and -9, those are technically like terms, even though they're pretty obvious. If there's no variables, you can always combine them. Okay, just you could add 5 plus -9, you could go 5 minus -9. Those create one single term. Not like terms. This one has a variable, this one doesn't. So since one has a variable, one doesn't, you couldn't combine those. You couldn't add them, you couldn't subtract them. 2x and 7x have the same variables, so you can combine them. 2x plus 7x would make 9x. 2x minus 7x would be -5x. Not like terms. 2x and 7y. Yes, they both have a variable, but they're different variables, so you can't combine those if they're not the same variables. 2xy and 8xy. Yes, you can combine those. Those are the same variables, so that would be, if you added them, it would be 10xy's. 2xy and 2x are not combinable because they don't have the exact same variables. One has just x, one has xy, so the second term has no y. 3x squared and 11x squared are like terms because they have the same variable and each variable has the same power. X has a power of 2 here, x has a power of 2 here. So that you could add those together to make 14x squared or subtract them to make -8x squared. 3x squared and 11x are not like terms. They have the same variable, but this one has a power of 2, this one has a power of 1. If there's no power there, it's always a power of 1. So they have different powers. This one's a little tricky to read. This is 2x squared times y to the 4th times z, and 3x squared times y to the 4th times z. Each power, or each variable, has the same power. X squared, y to the 4th, z to the 1st. So you could combine those and that would make 5x squared, y to the 4th, z. These ones, they're flipped a little bit. This one's 2v to the 5th, y to the 3rd, and this one's 2v to the 3rd, y to the 5th. So this v to the 5th would not combine with this v to the 3rd, and this y to the 3rd would not combine with y to the 5th. Different powers. So try to come up with a couple on your own and see if you can choose like terms that we could combine and terms that we could not combine. Go ahead and pause it and do that real quick. Okay, so we're going to practice this simplifying. 3k minus k. This problem, a lot of people make the mistake of subtracting the k and writing 3 because there's a k here and you're taking away a k, so they would cancel out. But that's not the truth. Okay, that's not how you would do this. That's not the right answer, because you actually have 3k and you're taking away 1k. Every single variable has a 1 out front if there's no other coefficient. And coefficient is just a fancy word for the number in front. So it would be 3k minus 1k, and you're left with 2k, as you can see. Next one, a little more complicated. It's -2 parentheses 2 times the quantity r plus s minus the quantity 2r plus 2s. In this case, there's a lot of work to do before we can figure out what our simplified answer is. Before we can just add or subtract like terms, we need to distribute. And actually, we're distributing twice here. I want you to think about -2 times r, -2 times s. That one's simple. But the next one's a little more difficult. This minus, it's like we're distributing a -1. Okay? So -1 times 2r is minus 2r, and -1 times 2s is minus 2s. Or you could think about it as plus a -2s and plus a -2r. Same difference. Either which way, we'd have to combine like terms at this point. So it's -2r and then plus -2r. Now here's a trick that a lot of people get messed up on. They're not sure whether to count the sign behind or the sign in front when we're combining like terms. It's always the sign in front. So we have -2r and minus 2r. So that means you can rewrite them in order like that. And then you have -2s minus 2s. We can rewrite them in that order. And when we combine them that way, it's easy to see it's negative 4r and negative 4s. An alternative answer would just be negative 4r minus 4s. Either one works. Okay, so you try. Y times 1 plus y minus 3y squared minus y minus 1. Is it A, negative 2y squared minus 1, B, negative 3y squared minus 1, C, y squared minus y, or D, negative 3y squared plus 2y plus 2? Go ahead and pause it and try. Answer is A, negative 2y squared minus 1. To practice these, you would go to page 15, 21 through 35, all. Looking at these problems, we would distribute first. So y times 1 is 1y. Y times y is y squared. And then we would combine like terms. What I like to do is I like to underline once the highest powers, and then twice the next highest powers, because these have a power of 1. If there's nothing there, it's a power of 1. And then if this one's all alone, I could put 3 under it, but that one's pretty much by itself. There's nothing happening to that. There's no terms to combine negative 1 with. But I could combine y squared and 3y. And I'll reorder this so that I have the highest coefficients, or highest powers first. Y squared minus 3y squared. And then, so those are out of the way. Then I have 1y. It's positive, so I put plus 1y. And then this one's minus 1y because of the sign in front. Remember, you always keep the sign in front. And then you end with minus 1. Highest power to lowest power. Now we can combine. Y squared minus 3y. Think about this as 1y squared. 1 minus 3 is negative 2. And then y minus y, those would actually cancel out. Positive 1 minus 1 is 0y. 0y is nothing. And then you bring down the minus 1. The answer is A. And that wraps it up for today.